Located in Antarctica on the Brunt ice shelf, this 1,500-metre square modular structure is made up of 8 prefabricated units. 2-bedroom pods sleep up to 52. The social module contains a kitchen, dining room and fully equipped gym. To protect its occupants, snowdrifts are neutralised by expandable hydraulic legs, whilst 4-metre-long skis allow the 100-ton structures to be towed across the ice, making it Antarctica's first relocatable research facility. Halley 6 is an extraordinary engineering achievement, but before its designers could even contemplate construction, they faced a seemingly impossible problem.
The biggest challenge of being on the Brunt ice shelf is the isolation. You have to be able to ship down every nut and bolt down to the very last thing that will be needed, because it's just not possible to pick up another screw or something.
Everything must arrive by sea. A 2-week voyage from Cape Town. The 3,000 nautical miles of ice fields pose a unique challenge for Captain John Harper.
Antarctica is a difficult place to get to. We have to keep a very close eye on what the ice is doing, because it will close the door on you. Conventional ships would get damaged very easily in the ice. They're not designed to hit anything apart from water, so they would very easily become damaged and would not last for very long.
So, how do you complete a journey across a seemingly impenetrable sea? This would not have been possible without one of history's brilliant innovators. Local engineer Kyle Ferdinand Steinhaus began looking for a solution. Focusing on the ships themselves, he recognized their shape was the problem.
Imagine this sharp, pointed edge of my sledgehammer is the bow of my boat. It's perfect for cutting through the water and the waves. But let's see what happens when it encounters the ice. Even though the sledgehammer hit the impact spot, it didn't cleave its way through the ice. And you can imagine, in a frozen river or an ice pack, this could be miles and miles long.
Steinhaus realized that if you approach the ice from another angle, it's a different story.
Wow! That was amazing! Instead of the force acting horizontally, trying to cut through, it's now acting vertically and through the thinnest cross-section. And coming from above makes a big difference.
Following on from a Russian design, Steinhaus set out to create a ship that could crash down on the ice. Rees is visiting Hamburg's preeminent hydrodynamic test center to investigate his outstanding maritime achievement.
This is one of the models used here at the facility to test icebreaking designs. And the bow does make use of the feature that Steinhaus came up with. A traditional ship's hull would have a sharp, pointed bow. What Steinhaus did was make a smoother, spoon-shaped bow.
The wider, shallow bow allowed a ship to slide up the edge of the ice before gravity forced it down on top. The ship's weight producing a huge shearing force, reducing the ice's resistance. In 1871, Steinhaus launched Icebreaker 1. Its spoon-shaped bow design has helped pave the way for many pioneering vessels that can now reach the planet's most inaccessible locations. To make the seemingly impossible journey to Halley 6 in Antarctica, Captain John Harper and his crew take to the helm of a Steinhaus-inspired engineering colossus, the ERNEST Shackleton.
The ERNEST Shackleton is specially constructed to be able to withstand big bits of ice, big bergs.
This 80-metre marvel tackles thousands of miles of frozen water in the treacherous Weddell Sea.
We are actually just coming to a bit of a sticky spot. I'm going to head down there to those pools, but it's going to be a bit crash and banging.
As the rounded bow of this 4,000-ton ship undulates over the ice, to avoid any ripping, its polar-grade steel hull is built streamlined, without stabilizer fins. A further reinforced band of steel known as the ice belt runs down its length to avoid crushing from built-up ice. But in these extreme conditions,
the bit that we're about to go through is probably 2 to 3 feet thick.
power is also key. 2 diesel engines throwing out 7,200 shaft horsepower keep the ice at bay.
But the secret is to actually just keep the ship moving, and that's why you're continually looking for the right way to go.
As the ERNEST Shackleton approaches Antarctica, it faces another seemingly impossible problem. In this wilderness of ice, there is no harbour. So how do you moor up? Its solution is to carve its very own customised dock out of the irregular edge of the ice mass, its thrusters turning the bow into a precision sculpting tool. However, reaching Antarctica is just the beginning.